Okay, so today I will discuss the few problems based on parallelogram law. So let's start with the problem number 1. So two forces are acting on a heavy body of mass m. This is the object or body. Force F1 is acting in this direction, force F2 is acting in this direction. The magnitude of force F1 is 400 Newton, F2 is 600 Newton, and the angle between these forces is 60 degree. Okay, and now you have to determine what is the resultant force and its direction with F1 or F2. So now first let's check whether we can use the law of the parallelogram to solve this problem or not. So first job is to make an equivalent force diagram. So if you make the equivalent diagram, F1 is acting in this direction, this is F2, angle is 60 degree. Okay, now so after making an equivalent force diagram, so I can represent one force on one side of the parallelogram, the second force on second side of parallelogram, then the diagonal of this parallelogram will represent the resultant force. Okay, so this is the resultant force R, and angle of R with F1 is alpha. So now let's first check what is the given. So the given values, you can make the table here first. The given values, so F1 is given, unit is Newton. F2 is given, theta between F1 and F2 give angle between F1 and F2 is given. Okay, and what need to determine? Resultant force and angle of this R with F1. Okay, so we need to estimate these two parameters. So since forces can be represented by two sides of parallelogram, so the resultant force is nothing but diagonal of this parallelogram. So we know from the law of the parallelogram. So now using so the resultant force will be F1 square plus F2 square plus 2 F1 F2 cos theta. Okay, so now we can substitute the value of F1, 400, 600 plus 2 into 400, 600 into cos 60 means 1 by 2. Okay, so cos 60 is 1 by 2. So after solving this under root, we will get R is around 871.7 Newton. And we also know that if the F1 is here and this is the F2 and this is the resultant force R, then the alpha, so we can estimate the angle. We know that the tan alpha is nothing but F2 sin theta plus F1 plus F2 cos theta. Okay, so we can find the tan alpha equal F2 600 into sin 60 divided by 400 plus 600 cos 60, 600 into root 3 by 2 divided by 400 plus 600 into 1 by 2. Okay, so we can find tan alpha is approximately 0.74. So alpha is tan inverse of 0.74. So alpha is approximately 36.5 degree. Okay, so this is the angle of R with force F1. Similarly, we can estimate the alpha prime, means angle of R with F2 is 60 minus 36.5 degree. Okay, so this is the solution of this problem. So now discuss problem number 2. I read the problem. A heavy box is pulled by means of two ropes as shown in figure. Okay, this one and this one. The tension in one rope is 2.6. Okay, so T1 is 2.6. Let's say tension T1 in this rope and T2 in this rope. So T1 is 2.6 kilonewton. If the resultant force of the two forces applied at point O is along the x-axis of the box, so this resultant force is acting at point O of this box along the x-axis, then find the tension in the other rope and magnitude of resultant force. Okay, so what is the tension T2 and then what is the magnitude of this resultant force we have to estimate. So first we need to check whether we can use parallelogram law or not to solve this problem. So first we make an equivalent force diagram. Okay, so let's say this is point O and this is the force T1 and this is force T2. Okay, so this is the resultant force. This is 32 degree, this is 28 degree. Okay, so the net angle is 60 degree. So net angle is 60 degree. So T1 and T2 both can be represented by two sides of this parallelogram. It means we can use the law of the parallelogram to resolve this problem or to find the resultant and one of the unknown forces. So now first write what are the given parameter. So given the T1 is given 2.6 kilonewton, T2 is, we need to estimate, R is, we need to estimate, alpha is 32 degree. Okay, so I defining angle with T1, angle of R with T1, and alpha prime, this is the 28 degree, angle of R with T2, and theta is 60 degree. Okay, so this is the angle between T1 and T2. So these are the parameters. Some few parameters are given and other we need to calculate. So now we know from the parallelogram law that the resultant force R is T1 is square plus T2 is square plus 2 T1 T2 cos theta, and tan alpha is T2 sin theta divided by T1 plus T2 cos theta, or tan alpha prime is T1 sin theta plus T2 plus T1 cos theta. Okay, because we have the alpha and alpha prime and we need to find the T2 and R. So for the R, the T1 is given, so until unless we will not estimate the value of the T2, we can't estimate the value of the R. And if we have another relations with theta and T1 and T2. Okay, so first I use, okay, so I am using this formula. So use the tan alpha prime, it means tan 28 degree is T1 sin 60 divided by T2 T1 cos 60. Okay, so tan 28 degree T1 is 2.6 kilonewtons into root 3 by 2 divided by T2 plus 2.6 into 1 by 2. So if I solve this equation, tan 28 degree T2 plus 2.6 divided by 2 . equal 2.6 into 3 by 2. So if I solve the equation, then I can estimate the value of the T2. Okay, so T2 will be around 2.9 kilo Newton. This is value of the T2. So now we know the T1 and T2. Now T1 is 2.6 kilonewton and T2 is 2.9 kilonewton. Okay, unit is same, so now we can use the resultant formula R equal to root 2.6 plus 2.9 plus 2 into 2.6 into 2.9 into cos 60. Okay, so 2.6 plus 2.9 square plus 2 into 2.6 2.9 into 1 by 2. Okay, so after solving this, root R will be around 8 kilo Newton. Okay, so we can use the law of the parallelogram to solve two force problem. So now let's discuss problem number 3. So I read the problem. A car is made to move by applying resultant force R of 200 Newton along the x-axis, and this R is developed due to two pulling forces F1 and F2 on two ropes. Estimate the tension in both ropes. Okay, so this is the one rope and this is the second rope, F1 and F2. There are two tension in this rope, and this is the resultant R which is acting along the x-axis. The magnitude of the R is 200 Newton. Okay, so angle of R with F2 is 25 degree, angle of R with F1 is 35 degree. Now we have to estimate the tension F1 and F2 in these ropes. Okay, so now first job is we need to check whether we can use the law of the parallelogram to solve this problem or not. Okay, so first task is to make an equivalent force diagram. This is point O, this is force F1, this is force F2. Okay, so now okay, so this is nothing but a parallelogram. So this is resultant R, this is 35 degree, this is 25 degree, and total angle is 60 degree. Okay, this is 60 degree. So if you look at the equivalent force diagram, then F1 and F2 both are represented by the sides of parallelogram, and this diagonal is representing the resultant force. Okay, so we can use the law of parallelogram to solve this problem. Now let's check what are the given. So theta is given 60 degree. Magnitude of resultant force is given 200 Newton. Alpha is given, that is angle of R with F1. Alpha prime is 25 degree is given. This is angle of R with F2. Okay, and then so we need to estimate F1 and F2. So first we write the formulation of law of the parallelogram. So we know that the resultant force can be written as F1 square plus F2 square plus 2F1 F2 cos theta. Okay, and the tan alpha is F2 sin theta divided by F1 plus F2 cos theta, and tan alpha prime equal to F1 sin theta F2 plus F1 cos theta. Okay, so we need to estimate F1 and F2. So since R is given, so if we can establish relation between F1 and F2, then we can estimate the value of one force from this expression. And since alpha and alpha prime is given, so we can estimate a relation between F1 and F2 by using these formulas. Okay, so we can use one of these formula. So let's say if I use the tan alpha equal to theta is the sin 60 F1 plus F2 cos 60 okay, so F1 root 3 by 2 F1 plus F2 equal to 10 35. So 10 35 F1 plus 1 by 2 F2 is equal to root 3 by 2 F2. Okay, now we can use the value of the 1035, that is value is 0.71 F1 plus 1 by 2 F2 equal to root 3 by 2 F2 or 0.71 F1 plus 0.71 by 2 F2 equal 0.86 F2, or we can solve this one. 0.71 F1 is 0.505 F2, or we can establish an relation between, so we can write the F1 is equal to 0.505 divided by 0.70 F2. Okay, so this implies, so F1 is approximately 0.71 F2. Now I can use the expression, because now I know the relation between F1 and F2. So R is equal to F1 square plus F2 square plus 2 F1 F2. 460 is 1 by 2. F1 is 0.71 square F2 square plus F2 square plus 0.71 F2 into F2. Okay, so F2 square 0.71 plus 1 plus this will be the 0.51 and 0.71. Okay, so R equal to F2 2.21, or R is F2 into 1.48. So R is 200 Newton equal to F2 into 1.48. Okay, so F2 is equal to 200 divided by 1.48. Okay, so the value will be around 1351.4 Newton. Okay, so F1 will be 0.71 into F2. So we can estimate the F1 into 1354. So F1 is equal to 959.5 Newton. Okay, so we can estimate the forces F1 and F2 if resultant force is given and one of the angle of R with P or Q is given. Okay, thank you.